Hello guys and welcome back. So now I have the animation. It took 12 minutes for it to sim 300 frames, and you can see everything is working as expected except this part here, which we're gonna fix. And I really like the motion. I think there's a lot of details, there's a lot of interesting motion. You can see here this part coming and rotating around the rest of the effects. The dissipation also is really cool. The stopping of the emission is very smooth, and it will be more visible once we render this, because right now it's abstracting, it's hidden underneath, and when we do the render with transparency we should be able to see through it. So I think I like everything. I don't have much to change here. I'm pretty happy with the motion and everything. The other things that we could do is try different combinations of the path. Try to increase the number of curves. Try to reduce the number of curves. Add more motion complexity to the motion. The only note I can recommend doing is not to change the curve while it's being used, because having an animated curve, especially with this at this density, will not result in what you expect to see here. So if you want to get motion within the curves, you would need to use just the normal pop force and add turbulence to that. And for this to fix this, we can increase a bit the attraction, make sure everything reaches one point, and then I'm gonna add a sphere with that kills any point that gets near there, and another box next to it that kills anything that go beyond that. But the important part is to attract them a little bit stronger. So let's do that. Here I'm going to create a pop kill node, and let's go back to the first frame, and I'm going to turn on bounding box, and I want it to be at 7. That's where the location is. I'm going to set it to sphere. We can increase the size a bit. So that's the first one. Delete anything that gets there, and then we can add another one that is a box, and with this one I'm going to increase its size, its height, and its width. I'm going to move it after the sphere, so anything that hits that will also get deleted. And once a particle is deleted, it's gone. It doesn't go in and then while it's hidden it's moving and then it comes back. Once it's hidden in the sim, once it's deleted, it's deleted. So that's gonna take care of the problem. We can increase the attraction as well, and I think that's pretty much it for this scene. The next effect that we're going to be creating is an idea where we want, let's say we have a city, a circular city with building blocks, and then we have streets in between, and we have some something happening in the center. Maybe a hero character landed, or some evil character landed, and they are gathering power from all the corners of the city or something like that. And we want to have some kind of energy flowing through the streets and reaching to this character. Okay, so let's first construct some proxy geo to represent the idea. I want to show this creation, the process here using SOPs, so that you guys learn a little bit more about SOPs and not just points and particles. So I'm going to start with a circle, and this is the city or where the effect is going to be happening. And I'm going to create roads. So I'm going to use a copy and transform node. And I'm going to rotate this. I made 6 copies, and I'm going to rotate it. Let's see. I'm going to make 4 copies, and the more copies we add, the more it's going to add. So 4, and then I'm going to extrude them. So I'm going to use an extrude volume node, and this simply give it some thickness. So move it up, and I'm going to transform it down. So I'm going to use a transform node and move it down. And I want to do a Boolean operation between these two to only to leave only the difference. I don't want the city, the roads to be inside this. So I'm going to use a Boolean node. Okay, and I'm going to tell it that the second input I want it to be treated as a surface, because the first input is 3D, the second input is a surface, and let's find the mode that works. So subtract, not working. So let's do the inverse. I generally spend a couple minutes trying this. I swap the connection so the circle is first. I'm going to set this to Boolean and subtract. So it's doing something. Let's see what's the difference here. First one. Yeah, this is how I had it before. And I simply need those guys deleted, but it's not working. So let me copy or redo what I had. So I'm going to use a poly extrude here. And I'm going to extrude, this is similar to the extrude volume node, except this is what I used and I'm not sure why it's working and not this this part. So let's transform it down a bit. So there's intersection with the ground. Okay, and let's do the Boolean node again. Okay, let's set this to surface. Yeah, and subtract. So it looks like this this is better. I just need these slices separate. And now we're going to add some buildings here and also trim them so they only show up in these rectangles or slices. Okay, let's scatter some points. And let's reduce the count, turn off relaxation, and let's create a box. Actually, I have the box here. I'm gonna copy 2 points, and let's copy the box to those points, and let's increase its size. Now I want to randomize the size of the box per point, so I'm going to create an attribute called pscale, and I'm going to randomize that. So let's create a random attribute. I'm going to call this pscale, and it's a float attribute, so I'll set this to 1. And I'm going to increase the scale, something like that, and let's increase the point, or let's turn on relaxation so the boxes are better placed. Let's increase them a bit more, something like that. And now we want to do another Boolean with these guys. So let's extrude these slices as well. Extrude them up. And make sure to turn on output back. This will fill in the bottom part. And let's transform the boxes so they are colliding with everything. Cool. And let's do a Boolean again and find the settings that works. Okay, so it's working there. Let's do let's change the mode to subtract. And there we go. Let's say these are the cities, the buildings. Probably it's too much. Something like that. Okay, and we want to have a source from this surrounding, and we want to have a goal here. And we want this source to be able to find the shortest path from the points into the center and build the necessary path. If it can come through this path, that's also fine. If it can come through, I don't know, here, maybe it finds a shorter path, it comes as well. So the way we're going to do that is using something called the find shortest path, and this requires a set of points that are connected together, and we can tell it to, this is my starting point and this is my goal, and this is where the area that you can travel through, and it will run the algorithm. Houdini will run the algorithm and will give you a set of curves to work with. So let's create all this. I'm gonna copy this circle, and I'm gonna scatter a lot of points on this. Okay, so these are the points, and I don't want the streets or the buildings. Sorry, I don't want the buildings to be included. Okay, there is no chance that the curve will pass through the building. I'm going to use a group node, and I'm going to connect the second input with the buildings. I'm going to turn on keep in bounding region. I'm going to change this to bounding object and set it to points, and I'm going to call this to delete. Okay, and let's blast those and remove them. Cool, so now we removed all the points that are inside this. And now we want to select a couple of points from the surrounding edge and use those to be the starting point, the emission point, or the starting point. And we want to select a goal layer that is at the center. So let's do this. Let's take this sphere, the circle, and extrude it. And I'm going to use inset to add a slight edge to it. I'm going to transform it in a tiny bit. That is too much. Something like that. And let's extrude it up. It doesn't look like it's working. So let's make sure we turn off front to only leave the extruded part from the inset. So this is the resulting geometry. And now we can do extrude volume. Sorry about that. Extrude volume. And that will give it some thickness. Let's use a group node. And again, group by region, second input, and object. And let's take a look and see why this is happening. It looks like the box is not inside at all, so I'm going to move it up a bit. And let's see. Sorry, we're going to change this to points. I'm going to call this start. And these points that we grouped now are the emission point. This is where the energy can come from. And for the goal, I'm going to create a group node. I'm going to change it to points. I'm going to change the name to end. We can click here, and now we can select by hand the point. But I don't want to do this because this is going to lock the selection to a set of specific numbers. I don't want that. I want to make it procedural as well. So I'm going to create a tick on bounding box. I'm going to change it to sphere and reduce it so it selects maybe 1 or 2 points. Let's try 1. Okay, and now let's create this find shortest path node. If we connect this guy, it's gonna ask for a starting point, start, and an end, and this should give us the result that we need. We're also going to change the mode here. What these are is basically, okay, given all these points, we have a start, which are those points. We have an end. How do you want the algorithm to run? It can say, okay, for each point, find 1, find an end, or for each end, find a start, or for each start and each end, find whatever works. We can also tell it to only run one time. Once it finds a result, it stops from searching. So all these are controlled via these modes here, and we're going to start use from each start to each end, and this will give us the best result in this example. So what is happening here, it says no path exists between start point and an end point, and that is true because all these guys are just points. There is no connection between them. Houdini is not magically gonna find these guys because they're next to each other. We need to connect them, we need to mesh them, create a geometry that connects all of them. And the easiest way to do this, because it's in a 2D space, it's not 3D, we're going to use a node called triangulate, and this does exactly this. So given a set of points, it's going to connect all of them. So it's view flat shaded with wireframe, and those are all the points. It's also going to inherit the groups and everything, so it's going to work perfectly. And now we connect that, and this is the result. And you can see it looks like a tree structure. So we have all the points that are at the center. They are nicely traveling through and reaching that. But if we template the city, the blocks, you can see that it's going inside. Some of them are going inside this. See, there's an intersection. I don't want that. And the easiest way to fix that is by processing this mesh using Boolean. So I'm going to connect this guy with this and tell it to remove anything that is in those areas. So the Boolean is going to change the mesh, and now if we do the find and search, you can see there is no more intersection between the two. Let's hide this, and now we have a perfect shortest path, and each one of them, they are trying to join each other and reaching a goal, basically. Okay, so let's do this. One thing I don't like is that the fact that there is a lot of points here. You can see that here. We have a lot of points. And one thing that I like to do is, as the point gets closer, I want to increase their chance of finding a source. So what we're going to do, if we go back all the way here, you see this density is very uniform. I want to change this. I want to make the points so that they are denser as they get closer to the center. And we're going to do that by processing this guy. So this sphere, this circle here, I'm going to subdivide it 6 times, it's fine, 5 times, 5 times. And I'm going to create an attribute. And Bob. Let's dive inside. And this attribute is going to represent the density, or the distance between each point and the center. Okay, so let's do that. Let's compute the length of the position, which is basically how far each point is from 0, 0, 0, and this sphere, this circle is at that location. And we know that the range is going to go between 0 to, let's see, 0 to 12.5, which is the diameter, or the circle, the radius of the circle. And let's connect this here. Let's change this to 1.5. And I want to invert the color from 1 to 0. Actually, this is 25, sorry. So now we're mapping everything. And let me change the background so it's easier to see. Okay. And I don't want this to be like that. I don't like this linear curve. So I'm going to use a ramp. I'm going to use a ramp here. I'm going to change that curve to look a bit different. So let's change it to a spline. And this is the original, this is the original result. Let's click here and expand this. And I'm going to change it to Bezier and Bezier here. I'm going to add a point here. I'm gonna make it brighter at the center, and we can move this, add another. So you can see now it's brighter at the center and darker. And I'm going to use this value to drive the scattering. You can see here there's this density control that we can use, but right now we don't have this attribute. We're viewing that as a color, and this guy expects a float. So let's export this as a custom attribute. The easiest way to do that in VOPs is using a bind export node, and we can declare attributes and create them on the fly here. I'm going to call this density, could name it anything, and it's a float by type, by default. So if we double click, we have density. We'll go back here, set it density, and there we go. We have less points and more as it progresses. Let's see how that looks. And I think this guy is not selecting one there. So let's extrude this a bit more to give it a higher chance of selecting some points. Let's scale it down. Yeah, something like that. Let's go up, and there we go. We have curves. Cool. So the next thing I want to do is let's do one more change here. I'm gonna scale this down so it selects less points. One point is good. And now the find shortest path, they all meet at one location, and they're not intersecting with anything. Okay, so in the next video we're going to look at how we can process this and make it generate more interesting curves that we can use. Thank you guys for watching, and see you in the next video. Look at how this is finding the shortest path between these two buildings. And it's snapping here. You know what? Let's do this before I stop. So this boolean here, I'm gonna peek it a little bit so that these small paths, we can close them. And the reason that we want that is because if the flow is too big, it's not going to be able to pass through this, and it'll probably end up intersecting with this. So let's add a peak node, and this is going to push the points along their normal. So we can simply do something like this, and you can see it's getting rid of those guys, and now it's not going there anymore. Hide this, and now it's much better. Cool. Thank you for watching, and see you in the next video. Bye bye.